The universe is very large, and most of it is very quiet. You can rest here for a while. There is nothing you need to do. Just listen, and let these soft facts about space drift through your mind like light moving slowly through the dark. A single photon of light takes about 100,000 years to travel from the center of the Sun to its surface. It bounces and bends through layers of dense gas for all that time, and then, once it reaches the edge, it crosses the remaining 93 million miles to Earth in just 8 minutes. Welcome. This is a place of slow and gentle things. You are going to hear 100 quiet facts about space, stars, and the distant galaxies that float beyond everything we can see from here. Each fact is small and soft. None of them need to be remembered. They are simply here to give your mind something calm to rest on, the way a boat rests on still water. You do not need to concentrate. You do not need to follow along carefully. You can simply let the words move through you, one by one, the way stars appear in the sky after the sun goes down, quietly, without announcement, one after another, until the whole sky is full and still. The nearest star to Earth, after the Sun, is called Proxima Centauri. It is about 4.2 light-years away. If you were traveling on the fastest spacecraft ever built by human hands, it would take you approximately 73,000 years to reach it. Space is not completely empty. Between the stars, there are very thin clouds of gas and dust. In some regions of space, there is about 1 atom per cubic centimeter. This is far less dense than the best vacuum humans have ever created in a laboratory on Earth. The Milky Way galaxy, the galaxy where our solar system lives, is estimated to contain somewhere between 100 billion and 400 billion stars. Scientists are not entirely certain of the exact number because much of the galaxy is obscured by dust and gas, making it difficult to count every star directly. Saturn is the second largest planet in our solar system. It is so large that about 760 Earths could fit inside it. And yet, Saturn is the least dense planet in the solar system. Its density is so low that if you could find an ocean large enough to hold it, Saturn would float. The light that reaches your eyes when you look at the night sky is old. The stars you see are not where they appear to be. You are seeing light that left those stars years, decades, centuries, or in some cases millions of years ago. The star itself may have moved, changed, or no longer exist by the time that light reaches you. A neutron star is the collapsed core of a massive star that has reached the end of its life. A neutron star can have a mass greater than the Sun, compressed into a sphere only about 20 kilometers across. A single teaspoon of neutron star material would weigh approximately 4 billion tons on Earth. The universe is about 13.8 billion years old. The Earth is about 4.5 billion years old. For most of the universe's history, Earth did not exist at all. There are more stars in the observable universe than there are grains of sand on all of Earth's beaches and deserts combined. This estimate has been calculated multiple times by different groups of astronomers, and while the exact numbers vary, the comparison consistently holds. Jupiter has at least 95 known moons as of recent counts. Its largest moon, Ganymede, is bigger than the planet Mercury. Ganymede is the largest moon in the solar system and has its own magnetic field. The Sun makes up about 99.8% of all the mass in the Solar System. All the planets, moons, asteroids, comets, and dust that orbit it together make up the remaining fraction. On the surface of the Moon, footprints left by Apollo astronauts between 1969 and 1972 are still there. The Moon has no wind, no rain, and no significant weathering processes to erode them. They may remain preserved for millions of years. The Andromeda Galaxy is the closest large galaxy to the Milky Way. It is approximately 2.5 million light-years away. Even so, it is on a slow collision course with the Milky Way. The two galaxies are expected to begin merging in approximately 4.5 billion years. A day on Venus is longer than a year on Venus. Venus rotates so slowly on its axis that it takes about 243 Earth days to complete one rotation. Its orbit around the Sun, however, only takes about 225 Earth days. The temperature at the core of the Sun is estimated to be about 15 million degrees Celsius. At the surface, the temperature drops to around 5,500 degrees Celsius. Scientists still do not fully understand why the Sun's outer atmosphere, called the corona, is actually hotter than its surface, reaching temperatures of several million degrees. Black holes do not pull things in the way a vacuum cleaner pulls in dust. Objects only fall into a black hole if they pass within a certain distance, called the event horizon. Beyond that boundary, gravity becomes so strong that not even light can escape. But at a safe distance, a black hole's gravity behaves much like that of any other object with the same mass. The International Space Station orbits Earth at an altitude of approximately 400 kilometers. It travels at about 7.7 kilometers per second, which means it completes one full orbit of the Earth every 90 minutes. Astronauts aboard the station see approximately 16 sunrises and 16 sunsets every single day. Mars has the largest volcano in the Solar System. It is called Olympus Mons. It stands about 22 kilometers above the surrounding plains, which is nearly 3 times the height of Mount Everest above sea level. At its base, Olympus Mons is wide enough to cover the entire state of Arizona. The cosmic microwave background radiation is a faint glow of light that fills the entire observable universe. It is the afterglow of the Big Bang, the ancient moment when the universe began expanding. This radiation has been traveling through space for about 13.8 billion years and has stretched as the universe has expanded, so it now appears as microwave radiation rather than visible light. Pluto was reclassified as a dwarf planet in 2006 by the International Astronomical Union. It takes Pluto approximately 248 Earth years to complete one orbit around the Sun. When Pluto was discovered in 1930, it had not yet completed even one full orbit since its discovery by the time it was reclassified. The Voyager 1 spacecraft, launched in 1977, is the most distant human-made object in existence. It has traveled beyond the boundaries of the Solar System into interstellar space. At the speed it is traveling, it would take Voyager 1 approximately 40,000 years to come close to another star system. Water ice has been found in many places throughout the Solar System. It exists on the Moon, on Mars, on several moons of Jupiter and Saturn, on comets, and in permanently shadowed craters near the poles of Mercury. Scientists believe that much of the water on Earth may have been delivered by comets and asteroids early in the planet's history. The Hubble Space Telescope, launched in 1990, has made more than 1 million observations since it began operating. It travels at about 5 miles per second and has logged more than 4 billion miles in orbit. Some of the images it has captured show galaxies that existed only a few hundred million years after the Big Bang. Light travels at approximately 299,792 kilometers per second in a vacuum. This speed is one of the fundamental constants of the universe. According to our current understanding of physics, nothing with mass can reach or exceed this speed. Europa, one of Jupiter's moons, is thought to have a global ocean of liquid water beneath its icy surface. The ocean may contain twice as much water as all of Earth's oceans combined. Because of this, Europa is considered one of the most promising places in the solar system to search for signs of life beyond Earth. A light year is not a measurement of time. It is a measurement of distance. 1 light year is the distance that light travels in 1 year in a vacuum, which is approximately 9.5 trillion kilometers. The Pillars of Creation is a famous region of the Eagle Nebula, about 6,500 light-years from Earth. The towering columns of gas and dust in this region are sites of active star formation. The image captured by the Hubble Space Telescope in 1995 became one of the most recognized images in the history of astronomy. Titan, the largest moon of Saturn, is the only moon in the solar system with a dense atmosphere. Its atmosphere is primarily nitrogen, similar to Earth's, but it also contains methane. On Titan, methane behaves much like water does on Earth, forming clouds, raining down, and collecting in lakes and rivers on the surface. These lakes are not made of water, however. They are made of liquid methane and ethane. The Oort cloud is a vast, distant region surrounding the solar system at its outermost edges. It is thought to be a reservoir of trillions of icy objects, some of which occasionally fall inward toward the Sun and become long-period comets. The Oort cloud extends so far from the Sun that its outer edge may be roughly 1 to 2 light-years away. White dwarf stars are the remnants of stars like our Sun after they have exhausted their nuclear fuel and shed their outer layers. A white dwarf is roughly the size of Earth but contains a mass similar to the Sun. Over vast timescales, white dwarfs are thought to slowly cool and fade until they become cold, dark objects called black dwarfs. However, the universe is not yet old enough for any black dwarfs to have formed. The distance between our solar system and the center of the Milky Way galaxy is approximately 26,000 light-years. Our solar system orbits the galactic center at a speed of about 230 kilometers per second. At this speed, it takes the solar system approximately 225 to 250 million years to complete one full orbit around the galaxy. This period of time is sometimes called a cosmic year or a galactic year. The surface of Mercury experiences some of the most extreme temperature swings in the solar system. During the day, temperatures can reach up to 430 degrees Celsius. At night, without an atmosphere to retain heat, temperatures can drop to negative 180 degrees Celsius. This range of over 600 degrees happens on the same planet, on the same surface, just on different sides facing toward or away from the Sun. Astronomers have discovered planets orbiting stars outside our solar system. These are called exoplanets. As of recent counts, more than 5,500 exoplanets have been confirmed. Many more candidates are awaiting confirmation. Some of these planets are similar in size to Earth and orbit within the habitable zone of their stars, where liquid water could potentially exist on their surfaces. The Sun loses mass constantly through a process called the solar wind. Charged particles stream outward from the Sun in all directions at speeds of several hundred kilometers per second. The Sun loses roughly 1 million tons of mass per second through this process. Over its entire lifetime, the Sun has lost a small but measurable fraction of its original mass this way. Io, one of Jupiter's moons, is the most volcanically active body in the solar system. It has hundreds of volcanoes, some of which eject plumes of sulfur dioxide hundreds of kilometers into space. Io's intense volcanic activity is caused by tidal heating, which results from the gravitational pull of Jupiter and the other large moons stretching and squeezing Io's interior as it orbits. The observable universe is estimated to be about 93 billion light-years in diameter. This is larger than the age of the universe in light-years might suggest, because space itself has been expanding since the Big Bang. Regions of space that were once close together have moved far apart over time, carrying the light from distant objects with them. Dark matter is a form of matter that does not interact with light or any other form of electromagnetic radiation. It cannot be seen directly, but its presence is inferred from its gravitational effects on visible matter, such as the way galaxies rotate and the way light bends around galaxy clusters. Dark matter is estimated to make up about 27% of the total mass and energy content of the universe. Neptune was the first planet to be discovered through mathematical prediction rather than direct observation. Astronomers noticed irregularities in the orbit of Uranus and calculated that another planet's gravity must be responsible. When telescopes were pointed to the predicted location, Neptune was found in 1846, within 1 degree of where the calculations suggested it would be. The Great Red Spot on Jupiter is a massive storm system that has been observed for at least 350 years. It is larger than the entire Earth. In recent decades, the storm has been observed to be slowly shrinking, though it remains one of the most prominent features of Jupiter's atmosphere. Comets develop their characteristic tails when they pass close to the Sun. The heat from the Sun causes ice and frozen gases in the comet's nucleus to vaporize, releasing dust and gas that form a glowing coma around the nucleus. Solar wind and radiation pressure then push this material away from the Sun, forming two distinct tails, a dust tail and an ion tail, that always point away from the Sun regardless of the direction the comet is traveling. The Moon is slowly drifting away from Earth. Each year, the Moon moves approximately 3.8 centimeters farther from our planet. This gradual separation is caused by tidal interactions between Earth and the Moon. Over billions of years, this slow drift has already increased the Moon's distance significantly from where it was when it first formed. Betelgeuse is a red supergiant star located in the constellation Orion. It is one of the largest stars visible to the naked eye. If Betelgeuse were placed at the center of our solar system in place of the Sun, its surface would extend beyond the orbit of Jupiter. Betelgeuse is nearing the end of its life and is expected to explode as a supernova at some point in the astronomically near future, though this could still be hundreds of thousands of years away. The James Webb Space Telescope, launched in December of 2021, is designed to observe the universe in infrared light. It is positioned approximately 1.5 million kilometers from Earth. Its primary mirror is 6.5 meters in diameter and is composed of 18 hexagonal gold-coated segments. It is capable of detecting the faint infrared light of some of the earliest galaxies in the universe. Stars are born inside clouds of gas and dust called nebulae. Gravity slowly pulls the material in these clouds together, and as it collapses, it heats up. When the core temperature becomes high enough, nuclear fusion begins, and the object becomes a star. This process can take millions of years depending on the mass of the forming star. The rings of Saturn are made primarily of ice and rock, ranging in size from tiny grains to chunks several meters across. The rings extend up to 282,000 kilometers from Saturn's center but are remarkably thin, averaging only about 10 meters thick in some places. Despite their vast extent, if the rings were compressed into a single body, they would form an object much smaller than Saturn's moon Mimas. Uranus rotates on its side. Its axis of rotation is tilted at about 97.8 degrees relative to its orbit around the Sun. This means that each pole of Uranus experiences about 42 years of continuous sunlight followed by 42 years of darkness. Scientists believe this extreme tilt may have been caused by a large collision with another object early in the solar system's history. The Crab Nebula is the remnant of a supernova explosion that was observed by astronomers on Earth in the year 1054. At its center is a pulsar, a rapidly rotating neutron star that emits beams of electromagnetic radiation. The Crab pulsar rotates about 30 times per second and is one of the most studied objects in the sky. The asteroid belt lies between the orbits of Mars and Jupiter. It contains millions of asteroids ranging in size from tiny pebbles to objects hundreds of kilometers across. Despite what is sometimes imagined, the asteroid belt is not a densely packed field of rocks. The average distance between asteroids is very large, and spacecraft have passed through the belt multiple times without incident. The Sun is classified as a yellow dwarf star, though it actually appears white when viewed from space. Its classification places it in the middle range of stars by size and temperature. There are stars far larger and far hotter than the Sun, and there are stars far smaller and cooler. In terms of the full range of stellar types, the Sun is a fairly ordinary star. Galaxies tend to exist in groups called galaxy clusters, which are in turn part of larger structures called superclusters. The Milky Way belongs to a small group of galaxies called the Local Group, which contains more than 50 galaxies. The Local Group is part of a larger structure called the Virgo supercluster, which itself is part of an even larger structure called Laniakea, a supercluster spanning about 500 million light-years. The speed of light in a vacuum is a constant, but light slows down when it passes through a medium such as water or glass. In water, light travels at about 75% of its speed in a vacuum. In some laboratory experiments, scientists have slowed light to remarkably low speeds by passing it through specially prepared materials cooled to near absolute zero. Absolute zero is the lowest possible temperature, defined as 0 Kelvin, or negative 273.15 degrees Celsius. At this temperature, particles would have the minimum possible thermal motion. Absolute zero has never been perfectly achieved in a laboratory, though scientists have come extremely close, cooling materials to within a fraction of a degree of it. The Moon is slowly drifting away from Earth. Each year, the Moon moves approximately 3.8 centimeters farther from our planet. This gradual separation is caused by tidal interactions between Earth and the Moon. Over billions of years, this slow drift has already increased the Moon's distance significantly from where it was when it first formed. Betelgeuse is a red supergiant star located in the constellation Orion. It is one of the largest stars visible to the naked eye. If Betelgeuse were placed at the center of our solar system in place of the Sun, its surface would extend beyond the orbit of Jupiter. Betelgeuse is nearing the end of its life and is expected to explode as a supernova at some point in the astronomically near future, though this could still be hundreds of thousands of years away. The James Webb Space Telescope, launched in December of 2021, is designed to observe the universe in infrared light. It is positioned approximately 1.5 million kilometers from Earth. Its primary mirror is 6.5 meters in diameter and is composed of 18 hexagonal gold-coated segments. It is capable of detecting the faint infrared light of some of the earliest galaxies in the universe. Stars are born inside clouds of gas and dust called nebulae. Gravity slowly pulls the material in these clouds together, and as it collapses, it heats up. When the core temperature becomes high enough, nuclear fusion begins, and the object becomes a star. This process can take millions of years depending on the mass of the forming star. The rings of Saturn are made primarily of ice and rock, ranging in size from tiny grains to chunks several meters across. The rings extend up to 282,000 kilometers from Saturn's center but are remarkably thin, averaging only about 10 meters thick in some places. Despite their vast extent, if the rings were compressed into a single body, they would form an object much smaller than Saturn's moon Mimas. Uranus rotates on its side. Its axis of rotation is tilted at about 97.8 degrees relative to its orbit around the Sun. This means that each pole of Uranus experiences about 42 years of continuous sunlight followed by 42 years of darkness. Scientists believe this extreme tilt may have been caused by a large collision with another object early in the solar system's history. The Crab Nebula is the remnant of a supernova explosion that was observed by astronomers on Earth in the year 1054. At its center is a pulsar, a rapidly rotating neutron star that emits beams of electromagnetic radiation. The Crab pulsar rotates about 30 times per second and is one of the most studied objects in the sky. The asteroid belt lies between the orbits of Mars and Jupiter. It contains millions of asteroids ranging in size from tiny pebbles to objects hundreds of kilometers across. Despite what is sometimes imagined, the asteroid belt is not a densely packed field of rocks. The average distance between asteroids is very large, and spacecraft have passed through the belt multiple times without incident. The Sun is classified as a yellow dwarf star, though it actually appears white when viewed from space. Its classification places it in the middle range of stars by size and temperature. There are stars far larger and far hotter than the Sun, and there are stars far smaller and cooler. In terms of the full range of stellar types, the Sun is a fairly ordinary star. Galaxies tend to exist in groups called galaxy clusters, which are in turn part of larger structures called superclusters. The Milky Way belongs to a small group of galaxies called the Local Group, which contains more than 50 galaxies. The Local Group is part of a larger structure called the Virgo supercluster, which itself is part of an even larger structure called Laniakea, a supercluster spanning about 500 million light-years. The speed of light in a vacuum is a constant, but light slows down when it passes through a medium such as water or glass. In water, light travels at about 75% of its speed in a vacuum. In some laboratory experiments, scientists have slowed light to remarkably low speeds by passing it through specially prepared materials cooled to near absolute zero. Absolute zero is the lowest possible temperature, defined as 0 Kelvin, or negative 273.15 degrees Celsius. At this temperature, particles would have the minimum possible thermal motion. Absolute zero has never been perfectly achieved in a laboratory, though scientists have come extremely close, cooling materials to within a fraction of a degree of it. The Sun is expected to remain on the main sequence, fusing hydrogen in its core, for approximately another 5 billion years. After that, it will expand into a red giant, growing large enough to potentially engulf the inner planets, including Earth. It will then shed its outer layers and leave behind a white dwarf at its center. The cosmic web is the large-scale structure of the universe. When viewed at the largest scales, matter in the universe is arranged in a pattern of filaments, sheets, and voids. Galaxies and galaxy clusters tend to congregate along these filaments, while the vast spaces between them are largely empty. This structure formed from tiny fluctuations in the density of the early universe that grew over billions of years under the influence of gravity. Pluto has 5 known moons. The largest, Charon, is so large relative to Pluto that the two objects are sometimes described as a double dwarf planet system. Charon is about half the diameter of Pluto. The two bodies are tidally locked to each other, meaning they always show the same face to one another as they orbit their common center of gravity. The surface of Mars is red because of iron oxide, which is rust. The Martian soil contains a high proportion of iron minerals that have been oxidized over billions of years. Mars also has the thinnest atmosphere of the rocky planets, with surface pressure less than 1% of Earth's atmospheric pressure at sea level. In 1977, 2 golden records were attached to the Voyager spacecraft before they were launched. Each record contains sounds and images selected to represent life and culture on Earth, including music, greetings in 55 languages, and natural sounds such as rain, wind, and waves. The records are intended as a message to any intelligent life that might one day encounter the spacecraft in deep space. Radio waves travel at the speed of light. If an alien civilization at the center of our galaxy sent a radio signal toward Earth today, it would take about 26,000 years to arrive. Any reply we sent would take another 26,000 years to reach them. A two-way conversation across such distances would unfold over timescales far beyond a human lifetime. The surface of the Sun is not solid. It is a layer of intensely hot plasma called the photosphere. Below it lie deeper layers of churning gas, and above it is the chromosphere and then the corona. The surface is constantly moving, with enormous convection cells called granules rising and falling as hot gas pushes up from below and cooler gas sinks back down. Halley's Comet is one of the most well-known comets visible from Earth. It passes through the inner solar system approximately every 75 to 76 years. It was last visible from Earth in 1986 and is expected to return in 2061. Historical records of its appearances go back more than 2,000 years. The dwarf planet Ceres is the largest object in the asteroid belt. It is approximately 945 kilometers in diameter and contains about one-third of the total mass of the entire asteroid belt. Ceres is roughly spherical in shape, which distinguishes it from smaller, irregularly shaped asteroids. Gravitational waves are ripples in the fabric of spacetime caused by the acceleration of massive objects. They were first directly detected in 2015 by the LIGO Observatory. The waves detected in that first observation were produced by the merger of two black holes approximately 1.3 billion light-years away. The detection confirmed a prediction made by Albert Einstein in his general theory of relativity in 1915, exactly 100 years earlier. The temperature of the cosmic microwave background radiation, the ancient light left over from the early universe, is approximately 2.7 Kelvin, or about -270 degrees Celsius. This makes it one of the coldest things that can be measured in the universe, far colder than any natural environment found in the solar system. Stars generate energy through nuclear fusion, a process in which lighter atomic nuclei are combined to form heavier ones, releasing energy in the process. In the cores of stars like the Sun, hydrogen nuclei are fused to form helium. This process releases an enormous amount of energy, which eventually makes its way to the surface and is radiated outward as light and heat. The Kuiper belt is a region of the solar system that extends beyond the orbit of Neptune. It is similar to the asteroid belt but far larger and wider, and it is populated primarily by icy objects rather than rocky ones. Pluto is one of the largest known objects in the Kuiper belt. The region is thought to contain hundreds of thousands of objects more than 100 kilometers in diameter, as well as trillions of smaller bodies. Magnetars are a type of neutron star with an extraordinarily powerful magnetic field. The magnetic field of a magnetar can be about 1,000 times stronger than that of an ordinary neutron star and about 1,000,000,000,000 times stronger than Earth's magnetic field. Magnetars occasionally release bursts of energy called starquakes, which can be detected across vast distances of space. The Sun rotates, but not uniformly. Because it is made of plasma rather than solid material, different parts of the Sun rotate at different speeds. The equatorial regions complete one rotation in about 25 days, while the polar regions take about 35 days. This phenomenon is called differential rotation. Miranda, a small moon of Uranus, has one of the most unusual surfaces in the solar system. It features an enormous cliff called Verona Rupes that is estimated to be between 5 and 10 kilometers tall. This makes it one of the tallest known cliffs in the solar system. The varied terrain of Miranda suggests it may have experienced significant geological activity or possibly a large impact at some point in its past. When two neutron stars collide, they can produce an event called a kilonova. These collisions release an enormous burst of energy and are thought to be one of the primary sources of heavy elements in the universe, including gold, platinum, and uranium. The gold in a piece of jewelry may have been forged in the collision of two neutron stars billions of years ago, long before our solar system formed. The atmosphere of Venus is composed primarily of carbon dioxide, with clouds of sulfuric acid. The greenhouse effect on Venus is so extreme that its surface temperature averages about 465 degrees Celsius, making it the hottest planet in the solar system despite being farther from the Sun than Mercury. The atmospheric pressure at the surface of Venus is about 90 times greater than Earth's sea level pressure. Spacecraft sent to the outer solar system must travel enormous distances. The journey from Earth to Jupiter takes several years even on the most efficient trajectories. The journey to Neptune takes even longer. The Voyager 2 spacecraft, the only probe to have flown past Neptune, took about 12 years to reach it after launch in 1977. The spiral arms of the Milky Way are not fixed structures rotating with the galaxy. They are more like density waves, regions where gas, dust, and stars are more compressed, similar to the way traffic slows and bunches up on a highway. Stars pass through the spiral arms over long periods of time rather than staying within them permanently. There are regions of space called giant molecular clouds that are among the largest structures in the galaxy. These clouds can span hundreds of light years and contain enough material to form millions of stars. Despite their enormous mass, the density of gas within them is still extremely low by everyday standards. They are sites of ongoing star formation and often glow with the light of newly born stars embedded within them. The Moon has a very thin atmosphere called an exosphere. It is so thin that molecules within it rarely collide with one another. The exosphere contains traces of various elements including sodium, potassium, and helium, some of which are released by the solar wind striking the lunar surface and some of which seep out from within the Moon itself. Pulsars are rapidly rotating neutron stars that emit beams of electromagnetic radiation from their magnetic poles. As the star rotates, these beams sweep across space like a lighthouse beam. When the beam points toward Earth, a pulse of radiation is detected. Pulsars rotate with extraordinary regularity, and some of them keep time more accurately than atomic clocks on Earth. The Drake equation is a formula proposed by astronomer Frank Drake in 1961 to estimate the number of technologically advanced civilizations that might exist in the Milky Way and with which communication might be possible. It takes into account factors such as the rate of star formation, the fraction of stars with planets, and the fraction of planets that develop intelligent life. The equation does not produce a definitive answer, but it provides a framework for thinking about the likelihood of other civilizations existing in the galaxy. Enceladus, a small moon of Saturn, has geysers that eject plumes of water vapor and ice particles from cracks near its south pole. These plumes feed directly into Saturn's E-ring. The water being ejected suggests that Enceladus has a subsurface ocean of liquid water, kept warm by tidal heating. This has made Enceladus one of the most interesting places in the solar system for the search for extraterrestrial life. The center of the Milky Way contains a supermassive black hole called Sagittarius A star. It has a mass approximately 4 million times that of the Sun. The first direct image of Sagittarius A star was captured by the Event Horizon Telescope collaboration and released in 2022. The image shows a glowing ring of hot gas surrounding a dark central region, the shadow of the black hole itself. Space is expanding. The universe is not static. Every galaxy beyond our local group is moving away from us, and the farther away a galaxy is, the faster it appears to be receding. This expansion is thought to be driven by a mysterious force called dark energy, which is estimated to make up about 68% of the total energy content of the universe. The nature of dark energy remains one of the deepest unsolved problems in all of science. The color of a star is directly related to its surface temperature. Cooler stars appear red or orange. Stars with intermediate temperatures, like the Sun, appear yellow or white. The hottest stars appear blue or blue-white. By analyzing the color and spectrum of starlight, astronomers can determine a great deal about a star's temperature, composition, size, and even its motion relative to Earth. The Andromeda Galaxy is visible to the naked eye on a clear, dark night. It appears as a faint smudge of light in the constellation Andromeda. What you are seeing when you look at it is the combined light of approximately 1 trillion stars, all blended together into a soft, diffuse glow. The light reaching your eyes left the Andromeda Galaxy about 2.5 million years ago, long before modern humans existed on Earth. Triton is the largest moon of Neptune and one of the most unusual objects in the solar system. It orbits Neptune in a retrograde direction, meaning it moves in the opposite direction to Neptune's rotation. This is unusual among large moons and suggests that Triton was not formed alongside Neptune but was instead captured by the planet's gravity at some point in the distant past. Triton is also slowly spiraling inward toward Neptune and is expected to eventually break apart and form a ring system within the next few billion years. The Sun produces energy at a rate of approximately 3.8 times 10 to the power of 26 watts. This is an almost incomprehensibly large amount of energy. In 1 second, the Sun releases more energy than humanity has consumed in its entire recorded history. Most of this energy radiates outward into space in all directions, with only a tiny fraction intercepted by the planets. Binary star systems, in which two stars orbit each other, are very common in the galaxy. Some estimates suggest that more than half of all star systems in the Milky Way contain two or more stars. Some binary systems are so close together that the stars nearly touch, while others are so far apart that they take thousands of years to complete a single orbit around their common center of mass. The surface of the Moon is covered in a layer of fine, powdery material called regolith. This layer formed over billions of years as meteorites and micrometeorites continuously struck the lunar surface, grinding the rock into fine particles. The regolith varies in depth from a few meters in some places to tens of meters in others. Beneath the regolith lies older, fractured rock called megaregolith. When a star much more massive than the Sun reaches the end of its life, it can explode as a supernova. A supernova can briefly outshine an entire galaxy, releasing an enormous amount of energy. The remnants of the exploded star are scattered into space, enriching the surrounding gas and dust with heavy elements. These elements eventually become part of new clouds of gas and dust from which future stars and planets form. Titan is the only body in the solar system other than Earth known to have stable liquid on its surface. Its lakes and seas of liquid methane and ethane are concentrated near its north pole. The largest of these, called Kraken Mare, is estimated to be about 400,000 square kilometers in area, roughly the size of the Caspian Sea on Earth. The magnetic field of the Earth is generated by the movement of molten iron in the planet's outer core. This field extends far into space, forming a protective bubble called the magnetosphere. The magnetosphere deflects the majority of the solar wind, preventing it from stripping away the atmosphere and protecting life on the surface from harmful radiation. Without this magnetic field, Earth's surface would be a far more hostile environment. The Voyager 1 spacecraft carries a copy of the Golden Record along with a cover that includes instructions for playing the record and a pulsar map showing the location of the Sun relative to 14 known pulsars. The pulsar map is intended to allow any intelligent beings who find the spacecraft to determine where in the galaxy it originated. Because pulsars slow down at known rates, the map could also allow the finders to determine approximately when the spacecraft was launched. Quasars are among the most luminous objects in the universe. They are the extremely bright centers of distant galaxies, powered by supermassive black holes actively consuming surrounding material. As matter falls into the black hole, it forms a hot accretion disk that radiates enormous amounts of energy. Some quasars are so bright that they outshine the combined light of all the stars in their host galaxy by a factor of hundreds or even thousands. The axial tilt of the Earth, approximately 23.5 degrees, is responsible for the seasons. As the Earth orbits the Sun, different hemispheres are tilted toward or away from the Sun, resulting in longer days and more direct sunlight in summer and shorter days and less direct sunlight in winter. Without this tilt, the Earth would have no seasons, and the temperature differences between the equator and the poles would be more extreme and constant throughout the year. Infrared astronomy allows scientists to observe objects that are too cool or too distant to be seen in visible light. Many of the cold clouds of gas and dust in which stars form are opaque to visible light but transparent to infrared radiation. Telescopes sensitive to infrared light can peer through these clouds and observe the young stars forming within them. The James Webb Space Telescope is specifically designed to conduct detailed observations of the universe in infrared wavelengths. The largest known star by radius is a red hypergiant called Stephenson 2-18, sometimes also referred to as RSGC 2-18. It has a radius estimated to be about 2,100 times that of the Sun. If this star were placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. Stars of this size are extremely rare and represent the upper limits of how large a star can grow. The night sky contains many objects that are not visible to the naked eye but can be seen with even modest binoculars or a small telescope. These include globular clusters, which are dense, spherical collections of hundreds of thousands of stars bound together by gravity. The Milky Way contains about 150 known globular clusters, most of them orbiting in the halo surrounding the galaxy's disk. Meteoroids are small rocky or metallic bodies moving through space. When they enter Earth's atmosphere, friction with the air causes them to heat up and glow, producing a streak of light called a meteor. Most meteors burn up completely before reaching the ground. Those that survive and land on Earth are called meteorites. Some meteorites are extremely ancient, dating back to the formation of the solar system about 4.5 billion years ago, and they provide valuable information about the early solar system. The Fermi paradox refers to the apparent contradiction between the high probability of intelligent life existing elsewhere in the universe and the lack of evidence or contact with such civilizations. Given the vast number of stars and planets in the galaxy, many scientists consider it likely that other intelligent life has existed or exists somewhere. The absence of any confirmed signals or evidence of such life remains one of the most thought-provoking puzzles in science. The planet Neptune has the strongest winds in the solar system. Wind speeds on Neptune can reach up to 2,100 kilometers per hour. These winds blow in the opposite direction to the planet's rotation in some regions. Neptune receives very little energy from the Sun due to its great distance, yet it generates more heat from its interior than it receives from sunlight, which helps drive these powerful atmospheric dynamics. The event horizon of a black hole is not a physical surface. It is simply the boundary beyond which escape from the black hole's gravity becomes impossible. An object crossing the event horizon would not immediately notice anything unusual at the moment of crossing. However, from the perspective of a distant observer, objects approaching the event horizon would appear to slow down and freeze due to the extreme warping of spacetime, gradually fading from view. Astronomers use a unit called the parsec to measure very large distances in space. 1 parsec is equal to approximately 3.26 light-years, or about 30.9 trillion kilometers. The word parsec is derived from the terms parallax and arcsecond, and it reflects the method used to measure the distances to nearby stars using the apparent shift in their positions as Earth moves around the Sun. The surface of Europa, Jupiter's icy moon, is crisscrossed with a network of long, brownish streaks and ridges. These features are thought to be caused by the movement of the ice shell above the liquid ocean beneath. Tidal forces from Jupiter constantly flex and stress the ice, causing it to crack and shift. Material from the ocean below may seep up through these cracks and deposit minerals on the surface. Carbon stars are a type of star with an unusually high concentration of carbon in their atmospheres. The carbon causes these stars to appear distinctly reddish or orange in color. Carbon stars are typically old stars that have processed helium into carbon in their cores and then mixed that carbon up into their outer layers through convective processes. They are among the reddest objects visible in the night sky. The Moon exerts a gravitational pull on Earth that causes the tides. As the Moon orbits Earth, its gravity pulls on the oceans, creating a bulge of water on the side of the Earth facing the Moon and another bulge on the opposite side. As Earth rotates, different coastal areas pass through these bulges, experiencing high and low tides. The Sun also exerts a tidal force on Earth, though it is smaller than the Moon's, and the two effects combine to produce the strongest tides when the Sun and Moon are aligned. There is a region between the Sun and the orbit of Mercury that has never been thoroughly explored by spacecraft. The Parker Solar Probe, launched in 2018, is designed to study the Sun's outer atmosphere and solar wind by flying closer to the Sun than any previous spacecraft. It uses the gravity of Venus to gradually reduce its orbit, eventually passing within about 6 million kilometers of the Sun's surface. The Milky Way is estimated to have a diameter of about 100,000 light-years, though some recent studies suggest it may be somewhat larger. Its central bulge is about 10,000 light-years thick. The disk of the galaxy, where most of its stars are concentrated, is relatively thin compared to its width, averaging about 1,000 light-years in thickness, though it thickens toward the center and has a slight warp toward its outer edges. Io's surface is so volcanically active that it is constantly being resurfaced. Unlike the heavily cratered surfaces of most moons in the solar system, Io has very few impact craters because volcanic activity buries them quickly. The surface is instead covered with lava flows, volcanic calderas, and sulfur deposits of various colors, giving Io a distinctive yellow, orange, red, and white appearance. The cosmic distance ladder is the series of methods astronomers use to measure distances to objects at various scales throughout the universe. Close objects can be measured using parallax. More distant objects are measured using standard candles, such as Cepheid variable stars, whose intrinsic brightness is known and can therefore be used to calculate distance. At the greatest distances, type Ia supernovae are used as standard candles because they all explode with approximately the same intrinsic brightness. A solar flare is a sudden, intense burst of energy from the Sun's surface caused by the release of magnetic energy. Solar flares can release as much energy as 1 billion hydrogen bombs in a matter of minutes. They produce streams of charged particles and radiation that travel outward through the solar system. When directed toward Earth, these particles can disrupt satellite communications, power grids, and GPS systems, and they can produce vivid auroras visible at lower latitudes than usual. The rings of Uranus are very different from the rings of Saturn. They are dark, narrow, and composed of particles that reflect very little light, making them difficult to observe. Uranus has 13 known rings. They were discovered in 1977 when astronomers observed Uranus passing in front of a distant star and noticed the star's light dimming briefly both before and after the planet itself blocked it, indicating the presence of rings on both sides. Astronomers have detected organic molecules in space. These include amino acids in meteorites and complex carbon-containing molecules in interstellar clouds. The presence of organic molecules in space suggests that the building blocks of life are distributed widely throughout the universe. Some scientists believe that these molecules may have been delivered to early Earth by comets and meteorites, potentially playing a role in the origin of life. The Sun's magnetic field is complex and constantly changing. Approximately every 11 years, the Sun goes through a cycle of activity during which the number of sunspots, solar flares, and coronal mass ejections increases and then decreases. At the peak of this cycle, called solar maximum, the Sun's magnetic field also flips, with the north and south magnetic poles switching places. This cycle has been observed and recorded for hundreds of years. Galaxy mergers are common events over cosmic timescales. When two galaxies collide, they pass through each other over hundreds of millions of years. The stars within them are so far apart that direct collisions between individual stars are extremely rare. Instead, the gravitational interaction distorts the shapes of both galaxies, triggering bursts of star formation and rearranging the distributions of gas, dust, and stars. The eventual result is often a single, larger elliptical galaxy. The Atacama Desert in Chile is one of the best places on Earth for astronomical observation because of its high altitude, dry air, and clear skies. Several of the world's most powerful telescopes are located there, including the very large telescope operated by the European Southern Observatory. The Atacama Large Millimeter Array, also located in the Atacama Desert, is a collection of 66 radio telescope antennas that work together to observe the universe in millimeter and submillimeter wavelengths. The concept of a multiverse refers to the hypothetical existence of multiple universes beyond our own observable universe. Some versions of this idea arise from interpretations of quantum mechanics, while others emerge from theories of cosmic inflation, which suggest that the rapid expansion of space after the Big Bang may have produced many separate regions of space that are causally disconnected from one another. The multiverse remains a theoretical idea and has not been observationally confirmed. Cepheid variable stars are stars that pulsate in brightness with a very regular period. The period of their pulsation is directly related to their intrinsic luminosity, meaning that by measuring how long a cepheid takes to complete one cycle of brightening and dimming, astronomers can calculate how bright it actually is. By comparing this to how bright it appears from Earth, the distance to the star can be calculated. Cepheid variables were instrumental in establishing that other galaxies exist beyond the Milky Way. The temperature of interstellar space, far from any star, is approximately 2.7 Kelvin, set by the cosmic microwave background radiation that permeates the entire universe. This temperature represents the average energy of the radiation left over from the early universe. In regions near stars, the temperature of surrounding space rises significantly due to the radiation and stellar wind emitted by those stars. Saturn's moon Hyperion has one of the most unusual appearances of any moon in the solar system. It is irregularly shaped, resembling a somewhat flattened and heavily cratered sponge. Unlike most moons, Hyperion does not rotate in a predictable, stable way. Its rotation is chaotic, tumbling in an unpredictable manner as it orbits Saturn. This chaotic rotation is thought to result from the gravitational influence of Saturn and Titan. The Hubble constant is a measure of the rate at which the universe is expanding. It describes how fast a galaxy is moving away from us for each unit of distance. Recent measurements of the Hubble constant using different methods have produced slightly different values, a discrepancy that scientists refer to as the Hubble tension. Resolving this tension is one of the important open problems in modern cosmology. The outer planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, are often called gas giants or ice giants. Jupiter and Saturn are composed primarily of hydrogen and helium in gaseous and liquid forms. Uranus and Neptune are classified separately as ice giants because they contain a higher proportion of heavier elements such as water, methane, and ammonia in their interiors, often in a dense, fluid state rather than solid ice. The Sagittarius dwarf spheroidal galaxy is a small galaxy that is currently being absorbed by the Milky Way. It orbits the Milky Way in a polar orbit and has already passed through the disk of the Milky Way multiple times. Each passage has stretched and distorted the dwarf galaxy, pulling streams of stars away from it. Some of these stars are now distributed in long streams around the Milky Way, detectable by their distinct chemical compositions. On Earth, the atmosphere protects the surface from most of the harmful radiation coming from space. High-energy cosmic rays, ultraviolet radiation, and X-rays from the Sun and distant sources are largely absorbed or deflected by the atmosphere and the magnetosphere. At high altitudes, such as on mountaintops or in aircraft, exposure to cosmic radiation is measurably higher than at sea level. The largest known structures in the universe are galaxy filaments and walls. The Hercules Corona Borealis Great Wall is one of the largest known structures, spanning approximately 10 billion light-years. These immense structures are not solid objects but rather vast concentrations of galaxy clusters connected by the gravitational web of dark matter. At these scales, the universe begins to appear almost uniform, with these structures representing the largest variations in density that exist. Stars in a galaxy do not all move at the same speed. In our own solar system, planets closer to the Sun move faster in their orbits than planets farther away, following the laws of gravity. One might expect the same pattern in a galaxy, with stars far from the center moving more slowly. Instead, observations show that stars throughout much of the disk of the Milky Way and other galaxies move at roughly similar speeds regardless of their distance from the center. This unexpected behavior was one of the first major pieces of evidence suggesting the existence of dark matter. The process of nuclear fusion in the Sun converts about 600 million tons of hydrogen into helium every second. In doing so, about 4 million tons of mass are converted directly into energy according to Einstein's equation relating mass and energy. The Sun has been fusing hydrogen in this way for about 4.5 billion years and has enough hydrogen remaining in its core to continue for approximately another 5 billion years. In the early universe, only the lightest elements existed. Hydrogen and helium, with trace amounts of lithium and beryllium, were produced in the first few minutes after the Big Bang in a process called Big Bang nucleosynthesis. All the heavier elements, from carbon and oxygen to iron and gold, were formed later inside stars and in stellar explosions. Everything on Earth that is heavier than helium was made inside a star at some point in the past. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, provided an enormous amount of information about Saturn, its rings, and its moons. At the end of its mission, Cassini was deliberately flown into Saturn's atmosphere, where it burned up. This was done to prevent any possibility of the spacecraft accidentally contaminating the moons of Saturn, particularly Enceladus and Titan, which are considered potential candidates for hosting life. The night sky as seen from the surface of Mars would look quite different from the night sky as seen from Earth. The two moons of Mars, Phobos and Deimos, would be visible, though they are much smaller and less bright than Earth's moon. The sky itself would be darker than Earth's night sky in some ways due to the thin atmosphere, but dust in the Martian atmosphere can scatter light and affect visibility. Earth would be visible as a bright star, and the stars themselves would appear in slightly different positions due to the change in perspective from a different location in the solar system. Neutron stars spin extremely rapidly, especially when they are newly formed. Some pulsars, called millisecond pulsars, rotate hundreds of times per second. These fast-spinning pulsars are thought to have been spun up by accreting material from a companion star, which transferred angular momentum to the neutron star and caused it to spin faster over time. The fastest known pulsar rotates at about 716 times per second. The James Webb Space Telescope has observed some of the earliest galaxies ever seen, capturing light from galaxies that existed only a few hundred million years after the Big Bang. These early galaxies appear surprisingly bright and massive, challenging some existing models of how quickly galaxies could have formed in the early universe. The data from these observations is still being analyzed and is expected to refine our understanding of galaxy formation and evolution over cosmic time. The atmosphere of Jupiter is divided into bands of clouds that circle the planet at different latitudes. These bands are called zones and belts, and they move in opposite directions relative to each other, creating shear zones where the wind speeds differ dramatically over short distances. The clouds themselves are composed of ammonia crystals, ammonium hydrosulfide, and water, arranged in distinct layers at different altitudes within the atmosphere. The concept of a habitable zone around a star refers to the range of distances at which a planet could theoretically maintain liquid water on its surface. This zone is sometimes called the Goldilocks zone because conditions within it are considered neither too hot nor too cold for liquid water to exist. The boundaries of the habitable zone depend on the size and temperature of the star, with larger, hotter stars having habitable zones farther out and smaller, cooler stars having them much closer in. When light from a distant star or galaxy passes close to a massive object such as another galaxy or a black hole, the gravity of that massive object bends the path of the light. This phenomenon is called gravitational lensing. In some cases, the bending of light can produce multiple images of the same background object, or distort it into arcs and rings. Gravitational lensing has become an important tool for studying the distribution of dark matter, which cannot be seen directly but bends light just as visible matter does. The largest ocean on Earth covers about 360 million square kilometers. This seems vast, but the subsurface ocean thought to exist beneath the ice of Europa could contain more than twice as much water. If confirmed, Europa's ocean would be the largest body of liquid water in the solar system, even though it is entirely hidden beneath a shell of ice estimated to be between 10 and 30 kilometers thick. Some stars exist in triple or even higher-order multiple star systems, where 3 or more stars orbit each other in complex gravitational arrangements. The stability of such systems depends on the specific configuration of the stars. Some triple systems consist of a close binary pair with a third, more distant star orbiting around them. The gravitational dynamics of these systems can be complex, and over long timescales, one of the stars may eventually be ejected from the system. The zodiacal light is a faint, diffuse glow that can sometimes be seen in the night sky along the plane of the ecliptic, the path traced by the sun, moon, and planets across the sky. It is caused by sunlight scattered off tiny dust particles that are distributed throughout the inner solar system. This dust is thought to originate primarily from comets and collisions between asteroids. The zodiacal light is most visible from locations with very dark skies, appearing as a soft, pyramidal cone of light extending upward from the horizon shortly after sunset or before sunrise. The Chandra X-ray Observatory is a space telescope launched in 1999 that observes the universe in X-ray wavelengths. X-rays are absorbed by Earth's atmosphere and therefore must be observed from space. Chandra has observed a wide range of X-ray sources, including black holes, neutron stars, supernova remnants, and hot gas in galaxy clusters. The telescope has a resolution sharp enough to observe details at distances of billions of light-years. Titan's thick atmosphere creates an orange haze that obscures its surface from view in visible light. The Cassini spacecraft used radar and infrared instruments to map Titan's surface beneath the haze, revealing a world with mountains, dunes, river channels, and lakes. The dunes on Titan are made of organic particles rather than sand. They are shaped by winds in Titan's atmosphere and can reach heights of about 100 meters and extend for hundreds of kilometers in length. The Magellanic Clouds are 2 irregular dwarf galaxies that orbit the Milky Way. They are visible to the naked eye from the southern hemisphere as faint, cloud-like patches of light in the night sky. The Large Magellanic Cloud is about 160,000 light-years away, and the Small Magellanic Cloud is about 200,000 light-years away. Both galaxies are undergoing active star formation and contain regions of bright, newly formed stars. A solar eclipse occurs when the Moon passes directly between Earth and the Sun, casting a shadow on Earth's surface. Total solar eclipses, in which the Moon completely covers the disk of the Sun, are only visible from a narrow path on Earth's surface called the path of totality. During a total solar eclipse, the sky darkens, temperatures drop, and the Sun's corona becomes visible as a glowing halo around the silhouette of the Moon. The fact that the Moon appears almost exactly the same size as the Sun in the sky is a coincidence resulting from the Moon's size and distance from Earth. The Spitzer Space Telescope, which operated from 2003 to 2020, observed the universe in infrared light and made numerous important discoveries during its mission. These included the detection of distant galaxies, the characterization of exoplanet atmospheres, and detailed observations of star-forming regions. Spitzer was placed in an Earth-trailing orbit around the Sun, which allowed it to drift away from Earth and avoid the infrared radiation emitted by Earth itself. When the universe was very young, within the first few 100,000 years after the Big Bang, it was so hot and dense that atoms could not form. Electrons and protons existed separately in a hot plasma, and light could not travel freely because it was constantly being scattered by the free electrons. When the universe cooled enough for electrons and protons to combine into neutral hydrogen atoms, light was suddenly able to travel freely. This moment is called recombination, and the light released at that moment is what we observe today as the cosmic microwave background radiation. The surface gravity on different bodies in the solar system varies enormously. On the Moon, gravity is about 1/6 of Earth's surface gravity. On Mars, it is about 38% of Earth's. On Jupiter, it is about 2.5 times Earth's. On a neutron star, the surface gravity would be approximately 200 billion times stronger than Earth's, making it impossible for any known material structure to maintain its shape on the surface. Sunspots are temporary regions on the Sun's surface that appear darker than the surrounding area because they are cooler. They form where strong magnetic fields inhibit the convective transport of heat from the Sun's interior to its surface. Sunspots can range in size from small features barely larger than Earth to enormous complexes that span many times Earth's diameter. They tend to appear in pairs or groups and are often associated with solar flares and other forms of solar activity. The Kepler Space Telescope, which operated from 2009 to 2018, was specifically designed to search for exoplanets by monitoring the brightness of stars and looking for the tiny dimming caused when a planet passes in front of its star. During its mission, Kepler observed more than 500,000 stars and confirmed the existence of more than 2,600 exoplanets. The data collected by Kepler fundamentally changed our understanding of how common planets are around other stars. Some galaxies have a very different structure from the familiar spiral shape of the Milky Way. Elliptical galaxies are roughly oval or spherical in shape and contain very little gas or dust. They are composed primarily of older stars and show little sign of active star formation. The largest galaxies in the universe are giant elliptical galaxies, which can contain trillions of stars and are often found at the centers of large galaxy clusters. These enormous galaxies are thought to have grown by merging with many smaller galaxies over billions of years. The thin disk of the Milky Way, where our solar system resides, is home to most of the galaxy's younger stars and active star-forming regions. The older stars of the galaxy tend to be concentrated in the central bulge and in the halo, a roughly spherical region surrounding the disk. The halo also contains globular clusters and streams of stars that were once part of smaller galaxies absorbed by the Milky Way over its long history. The soft light that fills the sky on a clear night, the countless points of stars blending into faint clouds of the Milky Way stretching overhead, is the accumulated light of hundreds of billions of suns, each one a world unto itself, each surrounded perhaps by its own planets, its own moons, its own quiet darkness. All of that light has traveled enormous distances to reach this moment, arriving gently, without urgency, settling across the sky the way stillness settles at the end of a long and restful day. The universe continues in all directions without a visible edge or boundary that any telescope has yet reached. In every patch of sky, no matter how small, there are galaxies beyond galaxies, each one containing billions of stars, each star a sun burning quietly in the dark. The scale of it is beyond what the mind can fully hold, and yet it is possible to rest within that vastness, to let it be large without needing to understand all of it, to simply be still inside a universe that has been here for 13.5 billion years and will continue for an unimaginably long time to come. The zodiacal dust cloud, the thin layer of interplanetary dust that fills the inner solar system, is constantly being replenished. As comets pass close to the Sun and lose material, and as asteroids collide and break apart, new dust is added to this diffuse cloud. Over time, the gentle pressure of sunlight and the gravitational influence of the planets causes this dust to slowly spiral inward toward the Sun, where it eventually evaporates. Without a constant supply of new material, the zodiacal dust cloud would disappear within a few tens of millions of years. Some of the oldest stars in the universe are found in globular clusters. These ancient stars formed in the early universe, within the first few billion years after the Big Bang, when the material available for star formation was almost entirely hydrogen and helium. Stars that formed during this early period contain very small amounts of heavier elements compared to stars that formed later, like the Sun, which formed from material already enriched by previous generations of stars. The rings of Saturn are young by cosmic standards. Recent research suggests they may have formed only about 100 million years ago, relatively recently in the history of the solar system. This would mean the rings did not exist when dinosaurs first appeared on Earth. The rings are thought to have formed when a large icy body, perhaps a moon or a comet, was disrupted by Saturn's gravity and broken into countless smaller pieces that spread out into a ring system. Light pollution from cities and human settlements has made it increasingly difficult to observe the night sky from many parts of the world. A large portion of the global population now lives under skies bright enough that the Milky Way is not visible to the naked eye. In the most light-polluted areas, only the brightest stars and planets can be seen. The preservation of dark sky areas has become an important consideration for both astronomers and those who value the experience of seeing a natural, unlit night sky. The Sun's energy output is not perfectly constant. There are small variations in the amount of energy the Sun emits over the course of its 11-year activity cycle. These variations are relatively small, amounting to about 0.1% over the cycle, but they can have subtle effects on Earth's climate. Over much longer timescales, The Sun has been gradually brightening since it first formed, and it will continue to grow brighter as it ages. The discovery of the cosmic microwave background radiation in 1965 by Arno Penzias and Robert Wilson was one of the most important observations in the history of astronomy. The two radio engineers initially detected the signal as an unexplained noise in their antenna and only later realized they had discovered the ancient afterglow of the Big Bang itself. The discovery provided strong observational support for the Big Bang model of the universe and earned Penzias and Wilson the Nobel Prize in Physics in 1978. Some exoplanets orbit their host stars at extremely close distances, much closer than Mercury orbits the Sun. These planets, called hot Jupiters, are gas giants that are tidally locked to their stars, meaning one side always faces the star and the other always faces away. The day side of a hot Jupiter can reach temperatures of several thousand degrees Celsius, while the night side is far cooler. Powerful winds circulate heat from the day side to the night side in these extreme atmospheres. The mass of the observable universe is estimated to be on the order of 10 to the power of 53 kilograms. This figure includes all the ordinary matter, dark matter, and the energy equivalent of dark energy within the observable universe. The ordinary matter, the kind that makes up stars, planets, and everything we can see, accounts for only about 5% of this total. The rest is in the form of dark matter and dark energy, both of which remain incompletely understood. Infrared light can reveal details about the universe that are invisible in other wavelengths. Dust clouds that block visible light are often transparent to infrared radiation, allowing infrared telescopes to peer into the dense regions where stars are forming. The heat signatures of planets, brown dwarfs, and other cool objects also emit strongly in infrared wavelengths, making infrared astronomy an essential complement to observations made in visible, ultraviolet, X-ray, and radio wavelengths. The Pleiades star cluster, also known as the Seven Sisters, is a group of young, hot, blue-white stars located about 440 light-years from Earth. The cluster is visible to the naked eye and has been recognized and named by cultures around the world throughout human history. The stars and the Pleiades formed together from the same cloud of gas and dust about 100 million years ago and are still relatively close together as they move through space. Brown dwarfs are objects that are too massive to be planets but not massive enough to sustain the nuclear fusion of hydrogen in their cores the way true stars do. They occupy a middle ground between the largest planets and the smallest stars. Brown dwarfs can fuse deuterium, a heavier form of hydrogen, for a period of time after they form, but this process is short-lived. After the deuterium is exhausted, brown dwarfs gradually cool and dim over billions of years. The interstellar medium, the gas and dust that fills the space between stars within a galaxy, is far from empty or uniform. It contains regions of hot, diffuse plasma, warm neutral gas, cold dense clouds, and everything in between. These different phases of the interstellar medium are in a rough balance maintained by heating from stellar radiation and supernova explosions on one side, and cooling through radiation and other processes on the other. The interstellar medium is constantly being stirred and shaped by the stars that form within it and explode at the ends of their lives. The atmosphere of a star, like the atmosphere of a planet, has distinct layers. In the outermost layer of the Sun's atmosphere, the corona, the temperature is several million degrees, far hotter than the visible surface below. The reason for this extreme heating is still not fully understood, though it is thought to involve the dissipation of energy from magnetic waves propagating outward from the Sun's interior. Understanding coronal heating is one of the ongoing areas of research in solar physics. The farthest individual star ever observed, given the nickname Earendel by astronomers, was detected using the Hubble Space Telescope with the help of gravitational lensing. It is located approximately 12.9 billion light-years away, meaning the light observed from it left the star when the universe was less than 1 billion years old. The star itself no longer exists in the form it had when that light departed, and may have long since ended its life in a supernova or collapsed into a black hole. Everything moves through space. The Earth moves around the Sun. The Sun moves through the Milky Way. The Milky Way moves through the local group of galaxies. The local group moves through the Virgo supercluster. And the supercluster itself drifts through the fabric of an expanding universe. Nothing in the cosmos is standing still. And yet from here, lying quietly in the dark, it is possible to feel completely at rest, held gently in place by gravity and stillness, while the universe moves slowly and endlessly around you, carrying everything forward through the soft and ancient dark.